This monster machine dwells in a world beneath our feet. It eats rock for a living, with steely teeth that can chew through nearly any surface on Earth. Its job? To do what was once impossible. Carve out passageways beneath cities, rivers, and even oceans. It's a tunnel boring machine, or TBM. But make no mistake, boring isn't what it is. It's what it does. Tunnels are some of man's most amazing engineering accomplishments. But to dig a tunnel is tough, dangerous work, which requires some monstrous tools. Like some super-sized drill, the tunnel boring machine carves subterranean pathways. The biggest of these technological termites stretches 150 feet long, 40 feet high, and weighs over 3,000 tons. This borer is only one part of a multi-unit device that, when fully coupled, looks like an underground train that stretches hundreds of feet. Turn this fella loose, and it can rip through 100 feet of rock in a day.
You're looking at something equivalent to maybe 6 or 8 railroad locomotives grouped together and then extending back for a couple of city blocks. It's really a lot of iron. If you think of an earthworm at 30 or 40 feet in diameter, 300 or 400 feet long, obviously something you wouldn't want to meet in a dark alley, but the earthworm advances through the ground and creates an opening as it goes, and I think that's very similar to what a tunnel boring machine does.
This mammoth worm is armed with an arsenal of super sharp wheels mounted on a massive cutting face. As the face spins, these wheels take a bite out of old Mother Earth.
You've seen the small little wheel that's on a glass cutter. Essentially, what our machines have are a series of discs similar to that little wheel that are mounted in such a way that they roll in concentric circles onto the rock. Each of those little wheels on our machines are between 17 and 20 inches in diameter.
As the dirt disintegrates, it's caught by troughs in the face, and then pulled into the machine and dropped onto a conveyor that carries it through the body and to the surface. But the true scale of a tunnel borer is hard to see.
They're rarely seen as a complete machine. When they're in the tunnel, they're impossible to see all at one time, and the job they're doing is hidden because it's underground. You're inside a very large machine, so you really can't see what's going on very well because it's like seeing the whale from the inside. It's hard to visualize what the entire whale looks like when you're standing in the belly.
In the belly of this beast, men and machines toil to ensure that this new underworld doesn't come tumbling down around them. 18-ton concrete blocks are moved underground and transported through the tunnel by train. Then, a hydraulic lifter hoists the concrete slab snugly into place, just behind the advancing face. The slabs support the surrounding weight and maintain the tunnel's integrity.
The lining essentially is made up of maybe 6 to 8 pieces of concrete. The erector grabs a piece of this, puts it into the bottom of the tunnel, grabs another piece, puts it on the left side, grabs another piece on the right side until it builds the full ring.
The end result? A 40-foot-high concrete tunnel. rock into rubble, the TBM burrows forward using 10 million pounds of earth-piercing pressure. To push that hard, the machine needs to get some serious grip, and using its giant hydraulic pads, the newly placed concrete provides the perfect perch to push off from. Forging forward 6 feet at a time, it loosens its grip, lines the tunnel with concrete blocks, regrips, and repeats. A spectacle of awesome power, performed with monstrous ease. Over 100 years ago, tunnel boring machines replaced dynamite as the best way to cut tunnels through the earth. One of the first was built by Colonel James Beaumont. In 1880, his pneumatic TBM bored over a mile near Dover, England, for a rail tunnel. In the 1950s, James Robbins used a newer version of a TBM to build a 15,000-foot sewer in Toronto, Canada. By the 1990s, the company he founded used 11 massive TBMs to dig the 31-mile-long tunnel under the English Channel, finally linking England and France. Opened in 1994 and nicknamed the Channel, it was an immense project that involved 15,000 workers and $15 billion.
There were several machines used for the English Channel. There were 6 different machines that went undersea. The smallest of the undersea machines were probably on the order of $20 million.
At that price, these metal worms are only used for tunnels at least a mile in length. But don't think these brutes go blindly about their business. A laser light guides the driver to keep the tunnel on course. In this world, mere millimeters matter.
It's almost like a computer game. They show a little picture of a mining machine and it'll be pointing like this or it'll be pointing like that, and in relation to an X where the axis is. Or it'll actually be a digital readout that says you 2 millimeters to the right or you 2 millimeters to the left. And you just keep nudging it back towards zero with your hydraulics.
Between the cutting face, the conveyor belts, the pumps and lining equipment, there are lots of places where a worker could end up as worm food.
Most frightening thing about a tunnel boring machine is being in front of it and hear somebody turn on a pump. That's the most frightening thing. Everything is so massive that you can't afford to make a mistake and move in the wrong direction at the wrong time. There's no second chance with most of the equipment. It is a crushing force. It's a very dangerous environment.
Risky business? Yes. But any worker will tell you, there's nothing like having a breakthrough.
There's some good holding through parties, and people are very happy, very cheerful, and there's a few bottles of champagne broken. It's really a celebration of a long job completed. So you've seen the one in the channel where these 2 guys crawl through with and shake hands. Everybody wants that job.
Tunnel boring machines have enabled man to take on Mother Earth and tear subterranean pathways between cities and even countries. Will continents be next? If so, these will be the machines to do it. One bite at a time.